Find cot theta. Hence, what is the value of the length, y? Let the given equation, y minus x equals z divided by 5, be equation 1, and, by Pythagoras' theorem, the sum of the square of x and the square of y equals the square of z, be equation 2. Square equation 1. It implies that the square of y minus x equals the square of z divided by 25. Cross-multiply and solve for the square of z. We have that the product of 25 and the square of y minus x equals the square of z. Substitute this value into equation 2, so that the sum of the square of x and the square of y equals the product of 25 and the square of y minus x. We call it equation 3. We can use the method of trial and improvement method to prove that left-hand side of the equation 3 equals its right-hand side. Let x and y be equals to 6 and 8, respectively. We now substitute these values into equation 3, so that the sum of square of 6 and square of 8 equals the product of 25 and the square of 8 minus 6. We obtain that 100 equals 100. This is a true statement. Since left-hand side of the equation 3 equals its right-hand side, x and y equals 6 and 8, respectively, is a solution to equation 1, as shown on the screen. Also, if we substitute x and y equals 3 and 4, respectively, the result will satisfy equation 3. Now, consider the given right triangle in the left-hand side. By trigonometric identity, cot theta equals 1 divided by tan theta, which equals to x divided by y. By substituting the values of x and y equals 6 and 8, respectively, into the above equation, we therefore have that cot theta equals 6 divided by 8. Which equals to 3 divided by 4. Hence, the required value of cot theta equals to 3 divided by 4. Solution to question 2. Label points A, B, C, D and E from triangle ADE. Using Pythagoras' theorem, the square of AD equals the sum of the square of AE and the square of DE. It follows that the square of AD equals the sum of the square of 5 and the square of 7, which equals to 74. Take the square root of the equation. We obtain that AD equals the square root of 74. We call it equation 1. Let angle ADE equals to theta. It signify that sin theta equals line D, E divided by line A, D, which equals to 7 divided by the square root of 74. We call it equation 2. Since line AUB equals to line AUD, which equals to the square root of 74. This is because the side lengths of a square are equal. Consider triangle ABE and use cosine rule. The square of y equals the sum of the square of line A, B and the square of line AE minus 2 times the product of line AB and line AE multiplied by cosine 90 degrees plus theta. Substitute values of line A, B and line AE into above equation. It implies that the square of y equals the sum of the square of square root of 74 and the square of 5 minus 2 times the product of the square root of 74 and 5. Multiply by cosine 90 degrees plus theta. Simplify, and we obtained equation 3, as shown on the screen. By trigonometric identity, cosine 90 degrees plus theta equals negative sine theta, which equals to negative 7 divided by the square root of 74. If we substitute the value of sine theta obtained in equation 2. Now, substitute this value of cosine 90 degrees plus theta we got into equation 3. It implies that the square of y equals 99 minus 10 times the product of the square root of 74 and negative 7 divided by the square root of 74, which equals to the sum of 99 and 70. The simplified result is equals to 169. Hence, the square of y equals 169. Take the square root of the equation, so that y equals the square root of 169, which equals to 13. Therefore, the required value of y is equals to 13 units.